Good morning all, this is Shiba. Now we are going to see about the microprocessor and microcontrollers UNIT-2 8086 bus structure. So here we are going to see about the system bus timing. In previous topic we have discussed about the timing diagram basics, how the timing diagram will be for each and every pins available in the 8086 microprocessor. And now we are going to see the bus timings for every instruction. Like for example, now first you can take memory read timing diagrams. So in memory read, what is the needed patterns for drawing these timing diagrams? First you have to give the input clock, that is the mandatory. So as we have seen in the earlier topic, one bus cycle need 4 T state. So I am here drawing T1, T2, T3, T4, 4 T states. And now I am going to take the input address. For finding the data, I am going to execute memory read. So I need to find the destination from where I need to read the data. So for that I need to get the address, valid address. So that is the second diagram. It will be starting after giving the clock pulse. And third, address or data. Now I have initiated the valid address. From that address I will be fetching the data. So address, and next is the data from memory. Last process, what is the main objective of my work? To read. So I am reading the data. A low signal will read the data. So RD bar represents the low signal, 0. So this low signal will read the data. So I have completed the read operation. Similar to that memory write operation. So here single changes, instead of read I am going to write the data. So last instruction alone you can see it changes to WR bar. It writes the data to the memory. In this bus timing, as I have mentioned, there are 4 T states available: T1, T2, T3, T4. First T state is used to initiate the clock signal to generate the control signals, whether you are going to read, write, or memory is going to be used, or input output devices is going to be used. That is indicated and address is placed. During T2 you will be initiating the clock, that is read or write signal. What is the process you are going to do? That signal will be issued. During T3 it accesses the data, allow memory to access the data, whether to read or write. And during T4 the data is completed, and so all the bus signals are deactivated. So this is the 4 T states operation. And you can see the setup and hold time. Setup time is nothing but the time before the rising edge of the clock, while data must be valid and constant, and hold time is the time after the rising edge. So setup time is before the rising edge, and hold time comes after the rising edge of the clock, during which the data must remain valid and constant. Wait state, as we have mentioned earlier, wait state is the extra clock period inserted between the two clock timings T2 and T3 to lengthen the bus cycles, in order for the process to make the wait and for getting the response. So ready signal is also available. It is the input sampled at the end of T2, and again is necessary for waiting also. After wait, whether if processor is ready means ready signal is used to indicate now you can process the data. Whenever this ready signal is 0 means our TW is inserted in between. That is the major concept available here. So these are all about the system timing basics. So how it takes the input instruction, how it processes the instruction, how it produces the output. Okay. You can see in real-time application this is used major for finding how much T state, how much wait state it has taken. For example, if you are running the processor, that is washing machine, means it waits. For example, for soaking period and all, it has to wait. It soaks the cloth, and after it then it rinses the cloth. Again it soaks the cloth. So this T state and all, wait state and all clearly explained using this system bus timing diagrams. Okay, that's all about the system timing diagrams basics. If you have any doubts in this, you can ask me and get the details. Thank you.